Good morning. We've been talking about space and space-time diagrams and various things that are invariant, other things that are not invariant. I want to stop just a little bit today and indicate how you can actually get some physics out of this. If O is an inertial frame and O bar, a frame of reference which is also inertial, starts off with a common origin, and according to the people of O, the origin of the O bar system increases at a rate v, then the relationship between the x bar, y bar, z bar, and t bar coordinates were given by the Lorentz boost. I'm going to leave this as an exercise for you. It's just a bunch of algebra. But if you solve these equations for t, x, y, and z in terms of t bar, x bar, y bar, and z bar, you get the following result. If I wanted to create a world of confusion, I could say that the velocity has flipped sign, or I could just say that this is the set of equations that tell me the unbarred coordinates of a point in space-time in terms of the barred ones. In pre-relativistic physics, before people knew about this whole speed of light business, they would have said the corresponding equations were these. First things first, I want to think about angles that light rays make with a coordinate axis. In the pre-relativistic case, t bar is really just the same thing as t, so I'm only writing a bar above it to remind myself of what my motivations are. At t bar equals 0, a light pulse is emitted from the origin of the barred system. It makes an angle of alpha radians with respect to the positive x bar axis. Since the speed of light is taken to be 1, the x-coordinate is the speed of light times cosine alpha times how much t bar has passed, and similarly for the y bar. Using the non-relativistic formula, x bar equals x minus vt, but x bar is also cosine alpha t bar. But since time is absolute, t and t bar are the same quantity, so x minus vt must equal cosine alpha times t. Y is the same thing as y bar, which is sine alpha t bar, but because time is absolute, that's the same as sine alpha times t, so I have a formula for y as well. So it turns out that x is the number v plus cosine alpha multiplied by t, and y is sine alpha times t. What I'd like to do is I'd like to eliminate the parameter, which, since I've written it in this format, will turn out to be pretty easy to do. Take the ratio of y and x, the t cancels out, and I find out that y over x must be sine alpha over v plus cosine alpha. Remember that v is the fraction of the speed of light at which the two reference frames are moving with respect to each other. In everyday life, v will be very, very small, This will approximately be sine alpha over cosine alpha, which is tangent alpha, which is the angle that the light ray makes according to the bar network. If v is not zero, of course, then this isn't exactly tangent of alpha. It's smaller than it. This is very interesting. This says that if the barred people emit a light ray that, say, makes an acute angle with the positive x bar axis, when observed by the unbarred system, the angle is not going to be given by alpha, it's going to be given by this quantity. That is, if I think of tangent of alpha as being the slope of the path, this slope is going to be smaller than that slope. The unbarred individuals will see the radiation being emitted as being focused more in the positive x direction than you would expect. I want to figure out what our Lorentz boost formulas say about this. So this is the Galilean Newtonian focusing. Starting with the observations of the Bard network again, the location of the light pulse is given by x bar equal cosine alpha t bar and y bar equal sine alpha t bar. Now we have to be careful about some things because time isn't absolute anymore. If I calculate the second equation divided by the first one, certain things will cancel out, but I still have a difficulty. In the first equation, x and t appear on both sides of the equation, so we're going to have to do something about that. Taking the ratio of the two equations, I find out that y is going to be tangent of alpha times gamma times x minus v times t. This is not entirely satisfactory because I'm wanting to eliminate the parameter. I want to get rid of the t. So I have to figure out some way of expressing this quantity, v times t that is, in terms of x. So we'll have to look into that. All I've got to work with is that. This is a formula that relates x and t when I'm talking about the location of this pulse of light. Taking the first of our two equations, though, it's not very difficult to solve it for t in terms of x for points that represent the location of the light pulse. Now, my y is going to be tangent of alpha times gamma times x minus v times t. So I need to calculate x minus v times t using this expression for t. This will express everything in terms of x, and I will have eliminated parameter t. I'll factor an x out of both terms. What will be left here will be a term equal to 1. 1 is some number divided by itself, so I'll combine the fractions in this way. So doing some algebra, it turns out that this factor x minus vt is 1 minus v squared over 1 plus v secant alpha multiplied by x. The reason that I want to know that is that this is the factor that was in my equation for the path of the light ray in the unbarred coordinate system. That is, this formula. Putting in what we have figured out what x minus vt to be equal to, we have this for our formula for the path of the light ray. On the other hand, gamma was 1 over radical 1 minus v squared, so I can do some canceling out here. When the speed is small compared to the speed of light, v will practically be 0. Radical 1 minus v squared will practically be 1, so this factor can be ignored for all intents and purposes. This is the result that came from the Galilean and Newtonian ideas. But as the speed begins to get bigger, closer to the speed of light, that factor, radical 1 minus v squared, becomes close to 0. This means effectively that the slope observed by the unbarred observers is going to be much smaller than would have been predicted by the Newtonian and Galilean ideas. This effect is observed in particle accelerators. Next, the velocity addition formula. Suppose that the group of people that make up the barred network observe an object starting at the origin of that network, moving in the positive x bar direction with speed u. I want to think about what the people of the unbarred system are going to measure. So literally writing down what x bar is in terms of the Lorentz transformation, also t bar, we find out that this must be true. Divide through by gamma to get rid of it, add v times u times x to both sides, add vt to both sides, factor the x out, factor the t out. X is u plus v divided by 1 plus uv multiplied by t. The derivative of x with respect to t is the number in the circle. This is the speed as measured in the unbarred system. Sometimes you'll hear people make this kind of argument. Suppose that in the barred system, an object is observed moving to the right in the positive x bar direction, that is, at 75% of the speed of light. X bar will be 0.75 times t bar. The u, the way we've written it before, would be 0.75. Let's say, in addition, that O bar is moving in the positive x direction in the usual setup with speed equals 0.75. If I just add the speeds together, Isaac Newton or Galileo would have thought that as observed in the unbarred system, the object is moving at 1.5 times the speed of light. Right?
Right? Wrong.
Using this relativistic formula that we've figured out, though, when you do the calculation, it ends up that the unbarred coordinate system will measure the object moving with a speed of 0.96, 96% of the speed of light. What if the movement as measured by the barred system was actually the measurement of a light ray moving down the positive x bar axis? In that case, u would be 1. What would the unbarred system measure? Before we do the calculation, it's worth commenting, based on our entire development here, we already know what the answer has to be. If it turns out anything other than what it has to be, our theory is inconsistent. Let's see. Do the calculation, you get 1 for an answer. This is what it had to be because part of the stuff that we've used to develop all of our ideas, really the only new thing, is the speed of light is a constant value in any inertial reference frame, whether it be O or O bar or some other inertial reference frame. If I had gotten any answer except 1 here, that would have meant everything we've done, somehow there's a logical error in it. I think I'm going to call it quits on this video. Maybe I'll make a little video about the alleged paradoxes of special relativity, and then we're going to have to talk about energy and momentum before we can do any more physics. Until then, I hope everybody has a good day. I'll talk to you again soon.